In this video today, we're going to recall the fundamental quantities of mass, length, time, current, and temperature, and their related symbols within the SI conventions. We're also going to recall that the physical quantities usually expressed as a product of a number and a unit. We're also going to recall the base unit for some of the fundamental quantities indicated in 2.2 and their related symbols, and also going to show a diagram of 1 meter. We're also going to explain the need for the importance of standard in measurements. And these are all things that we should know at our level, which is grade 9, and our teacher has already expressed the need for us to know this if we want to have a career in physics. Now, we're going to go down straight to the SI units. Most scientists use SI units. The basic SI units for measuring mass, time, and length are the kilogram, the second, and the meter. From these base units come a whole range of units for measuring volume, speed, force, energy, and other quantities. Other SI base units include the ampere for measuring electric current and the Kelvin for measuring temperature. Mass. Mass is a mysterious property. It affects how objects behave in 2 ways. All objects are attracted to the Earth. The greater the mass of an object, the stronger the Earth's gravitational pull is on it. All objects resist attempts to make them grow faster, slower, or in any different direction. The greater the mass, the greater is the resistance to change in motion. This does not really link to fundamental quantities directly but indirectly. It doesn't link, but these are just some facts that you should know also at your level. The other thing that we're going to cover in the video is derived quantities and units and prefixes and convolutions, which is later on. But there is also one table that is a standard and which is the inaugural or for any physics student. Quantities, the main one, mass, length, luminous intensity, time, and the base units being kilogram, shortened kg, meter, m, candela, cd, seconds, s, and other little important ones that we use in our everyday life. The quantities being current, temperature, and amount of substance, AMT for short. Ampere, A, temperature, K, amount of substance, mole, shortened MOL. They are also called base units. And for more videos, and for more things which we're going to talk about later, which is our derived quantities and units and our prefixes and convolutions, with physics with us. We're both of us from the same institution, and we're going to do derived quantities and units. We spoke about earlier that while I was doing fundamental quantities with you guys, I said that I will later on be coming to the derived quantities and units. And later on in the third part, we're going to do prefixes and convolution, which will be done by another points. What that we always start with what we should know at this level, and what that we should know at this level is that we should be able to recall that derived quantities and their related units are produced by multiplying and dividing fundamental quantities and their units respectively. Another thing that we should be able to do at this level is recall the special names given to the unit of force, power, energy, frequency, charge, and their derivations from these units. And another thing that notes that not all derived quantities are special names for the units, as in the case of acceleration and velocity. And this is all section 1 in Introduction to Physics syllabus. And my friend Jimmy will take you through derived quantities and units.
Okay, basically right now I'm going to tell you about what is a derived unit. Derived units is basically the second part of fundamental quantities. SI derived unit. The International System of Units, SI units, specifies a set of 7 base units from which of all other SI units of measurement are derived. Each of these other units is either dimensionless or can be expressed as a product of positive or negative, but usually integral powers of one or more of the base units. For example, the SI derived unit of area is the square meter. Meter squared, that's the derived unit right there. That's how they got that for area. And the SI derived unit of density the kilogram, per cubic meter, the degree Celsius has a somewhat unclear status and is arguably an exception to this rule. The names of SI units are written in lower.
Hey, turn up.
Afternoon.
Last
We and
word.
my colleagues are back to end our free course series, and we'll be in the last segment. Our free course series, we looked at fundamental quantities, derived quantities and units, and we will be looking at prefixes and conversions. As you know, there are many different prefixes, and me and my colleagues will just go over a few with you guys. First, there's giga,
which is 10 to the power of 9.
and these are the powers.
And the symbol is G. Yes.
And then we have mega,
Mega.
Megatron.
10 to the power of 6. And our prefix is M, a capital M. Big M.
Yeah, man.
and then we have kilo,
Kilo.
Kilolo.
10 to the power of 3. A small K.
So as you know, from now on, all the symbols will be in small letters. Then we have deci, and then the symbols will start to have a negative sign in front of the number.
10 to the power of -1. Small d. Okay. Next.
And then centi,
Centi. 10 to the power of -2. Small d. C. Next.
and then we have milli,
My woman.
10 to the power of -3. Small m.
and then we have micro.
Micro equals 10 to the -6. 10 to the -6.
So before we end, we'll just go through it fast with you guys. For giga, it's 10 to the power of 9 as a positive 9 with a capital G as a symbol. Then we have mega with 10 to the power of 6 and that's positive with a big M. And then we have kilo, which is 10 to the power of 3, that's a positive 3 with a small k as the symbol. Then we have deci, which is 10 to the power of -1 with a small d. Then we have centi, which is 10 to the power of -2 with a small d also. And then back on this side we have milli, which is 10 to the power of -3 with a small m. And then we have micro, which is, and that's another way to write it, shortened form, with 10 to the power of -6 and the symbol is small m.
This is the end of our physics with us. I hope I hosted Kofi, Jaden, Amani, the cameraman, and Ryan, which is somewhere in the I hope in our short video, also known as Sky. I hope you learned in our short videos fundamental quantities, derived quantities and units, prefixes, and conversions.
And hopefully you could use this video to study and you will surely pass. Thank you very much.
Thank you.